All right, we're going to cover 2.4. Now, first thing I want to tell you, 2.4 is a combination of everything that we've been doing. So 2.4 is mixing, addition, subtraction, multiplication, and division. So we are just solving what they call multi-step inequalities. So let's just jump right into it. You're going to have some multiplication, you're going to have some division. It's not difficult to do, it's just going to have to watch what you do. So let's look on page 46 in your note packet. This is going to be number 1. We have 3x minus 2 is less than 10. Now in this particular video, I am not going to do every single problem. I am going to skip them and I will just have it pop up the answer for you to check. So for these, I am just going to pop them up. We're not going to graph them and write every single step, but I will expect you to graph them on your homework. So this is just basically getting you through the hoops of solving with inequalities and nothing further. All right, here we go. First step, we know in multi-step problems, we always have to check to see if we can combine like terms on either side. And in this case, no, we cannot. There is no clearing fractions or decimals. So the next step is just starting your solving. We have multiplication and we have subtraction. You always do addition, subtraction before you do your multiplication division. That should be your final step. So here we go. I'm going to take and do the opposite of subtraction, which is adding 2. So 3x is less than 12. I divide by 3, so x is less than 4. At this stage of the game, you should be able to graph that. So number 2, I'm going to put it up here, and I want you to solve this one on your own. The answer will appear when you come back to the video. Okay, now for number 2, you should have gotten -2 for your answer. Be very careful. You're not going to flip the inequality signs on this one. Here's the reason. You were dividing by a +4, not a -4. Remember, just because you get a negative answer doesn't always mean that you're going to be flipping the inequality sign. Okay, look at number 3 and number 4. We have 2 of them. Both of them have a lot of quirks. So the first thing we're going to do in number 3 is we're going to take and clear the fraction. So I'm going to take and multiply it by, you're right, -3. So when you multiply by -3, this is going to do a lot of things. It's going to change your inequality sign, and it's going to flip everything around. So this becomes -6 plus b. This becomes less than or equal to -9. And now all you have to do is take and add 6 across, and you're going to get b is greater than or equal to -3. Apply these same tactics to number 4. Remember, whenever you multiply or divide by a negative, it changes all the inequality or all the signs and the inequality sign. All right, take care of it. Unpause the video when you're ready. Okay, so this one was a little bit nicer. After you multiplied by -2, since that was my only denominator, it ended up making it go quite quickly. So all the numbers became positive and your inequality sign switched. So the last step was just to subtract by 12. Okay, and that's how we got our 4. Let's look at number 5. So number 5 is 8 is less than or equal to -4 parenthesis d plus 1. Now, I know we taught you to do distributive property, but this is counterintuitive. If they're held by multiplication, you can actually take and divide both sides by that number out front. So if we take and divide both sides by -4, this is going to cause my inequality sign to switch. So this becomes -2. And this just becomes d plus 1. So now I'm going to subtract 1 from both sides, and I get -3 is greater than or equal to d. So when we rewrite this, we are going to say d is less than or equal to -3. Once again, this one has 2 flipping inequality signs. So we flipped it once because we multiply by or divided by -4, and then we flip it again because of the rewrite. So let's look at number 6. 6 is 5 minus 2n is greater than 8 minus 4n. So this one has a number on each side, a coefficient, I should say, on each side, and then a variable number on each side. So let's take this one step at a time. Let's take care of the variable numbers first. So negative 2n and negative 4n. Negative 4 is technically smaller, so I'm going to add it across so that I get 5 plus 2n is greater than 8. I'm now going to take and subtract 5 across so that we start isolating the n. And then the last step, of course, is divide by 2. Now, the good thing is, by the time you get to this part of your assignment, we're not asking you to take and graph these. We just want to know, can you solve these? So it kind of makes it easier. So let me put 7 and 8 up, and I want you to work those two first, and then we'll look at 9, 10, 11, and 12 from there. All right, so let me switch the page out so we have more room. Slide down our paper. And number 7 is 6h minus 18 is less than 6h plus 1. And number 8 is 3p plus 4 is greater than or equal to negative 4p plus 25. All right, I'm going to pause the video. I want you to take a moment and work both of those problems out and then check this. Okay, hopefully you've taken the time to pause that. Let's look what we got. Number 7 is actually one of your specials. That's what we covered in the previous chapter. So you do still have all reals and no solutions. What makes a difference between the two? Very simply, the variable drops out, and then if the inequality is true, then it's an all reals. Negative 18 is smaller than 1, so therefore it is an all real numbers, or infinite many solutions, depending on which way you would like to put it. I'll take either. Number 8 is just a straightforward problem. And by the way, with number 7, what you would tell me when you graph it, it would be everything. So you would actually shade the whole graph if you were asked to graph that. The other way they're going to have you write it sometimes, if you want it as an inequality, is negative infinity to infinity, which that's just starting to get you into some of this stuff. But that is another way to say that everything applies. All right, now on number 8. Number 8 is just a straight solving. We added the 4p across. We got 7p. We subtracted the 4 across and got 21. We divided by 7 and we got 3. All right. So now let's look at 9 and 10. 9 is going to be very reminiscent of 7 and 8. So 9 is 7j minus 4j plus 6 is less than negative 2 plus 3j. I know my j's look kind of like semicolons, but they're basically j's. Number 10 is going to be 12 times 1/4 w plus 3 is less than or equal to 3 times w minus 4. Now, this particular one, do not clear the fraction, because when you multiply a 4th times 12, that's the same as saying 12 divided by 4. So you'll get the gist when you work it out. All right, good luck. Okay, so for this particular one, for 9 and 10 both, once you take care of combining like terms and then solving, you notice that you get 2 mismatched inequalities. 6 is not smaller than negative 2, so that's false. 36 is not smaller or equal to negative 12. That is false. So both of those are a no solution. So for this particular 2, you have no solutions. Do you see the difference? Let's take a moment and move back down to 7. So 7 and 9, if you look at the 2 inequalities, let me kind of push it back up a little bit. The 2 inequalities that we see, this made a true statement. This made a false statement. True statements are all reals. False statements mean that they have no solution. You cannot do anything with them. All right. So now that you've had a crash course, we have 2 story problems that we need to do. So take a minute, read those, and then we're going to go through. Okay, so let's look at number 11. Number 11 says, find the value of k for which the solution of the inequality is all real numbers. So what I'm saying is, what do I have to multiply this 4 by to get negative 12? Because all real numbers means that the variables will be the same on both sides. Well, if I want to make this negative 12, k would have to equal negative 3. So let's put in our hypothesis and see what we get. So if I had negative 3 here, this becomes negative 12r plus 45 is greater than or equal to negative 12r minus 9. The negative 12r's are going to drop out. So I get 45 is greater than or equal to negative 9. So this makes it a true statement in which it wanted. Now, number 12 is asking the same thing, only making it a no solution. So what do I have to multiply the k by, or the number times the k, to get a no solution? In other words, what's it going to take to make this work? This one's a little more complex. First, we have to do some combining of like terms. So let's get some of this stuff combined first to make this a little easier. If you look at this, I can combine these two here. So I'm going to take and subtract 2kx. So I get negative 3k is less than 2x plus 4, and this is going to be 1kx. So now let's take and do it this way. What can we multiply by? Well, if we put in a 1, that's not going to work. Okay, because 1's just going to keep it. Negative 3, this right here is not going to cancel out. So we want stuff that's going to cancel out. So if we look at it, let's try 2. So let's try negative 2. So if I have 3 times negative 2 is less than 2x plus 4 times, it's going to be negative 2x, because I have to put the negative 2 in front. So negative 2x and negative 2 cancel out, which is kind of what we were going for here. So if these two here, sorry about that, I didn't get it far enough up. If these two here cancel out, that leaves me 6 is greater than 4. Is that a true statement? And the answer is no. So this is a no solution, because the two do not match. All right, this is the end of 2.4. Make sure you complete your homework after you watch this so that you don't forget how to do it.